Hello everyone. So we are back here with a new chapter of chemistry, that is structure of the atom. Now you have already read that atoms and molecules, they are the fundamental basic units of matter. Matter, whether solid, liquid, gas, everything is made up of small atoms. The pen we have here, this is also made up of small atoms. This is a matter. Our body, that is also matter. Air, it is also made up of small atoms. This whiteboard, anything around us is made up of very small atoms. And we learned that atoms are so small. This is, of course, I'm making a very big atom here so that you all can see it. But we know that atoms are very small. We learned they are the smallest particles. Right? Smallest particles. And we also learned this, that they are indivisible. They are so small that they cannot be seen by naked eyes. They are so small that they cannot be divided further. Right? This is what we learned. And in this chapter now, we are going to learn how atoms of one element, they are different from the atoms of the other element, or are they really indivisible? Can they not be further divided anymore? So that is what we are going to learn in this chapter. Now you have learnt about static electricity. That is, when we rub two things together, that becomes electrically charged. Like when you were small, you must have played this game also, that you take bits of paper and then you take a plastic scale and rub it with your dry hair, or you rub it on your coat or blazer, and then try to bring that scale near the bits of paper. What do you observe? The bits of paper, they get attracted towards the scale. How is that possible? You're not even touching those bits of paper with the scale. Right? That is because that scale, when you rub it with your dry hair or with your blazer that is made up of woolen garment, then it becomes electrically charged. Or when you rub your comb, when you just move your comb in your hair and your hair is very dry, you see that after some time it becomes charged. Right? So that means there is some charged particle inside the atom. Right? Now we say atom is indivisible. But it was discovered that it has got some small particles inside it. Right? That is why it becomes charged. So now we are going to study about these charged particles. J.J. Thomson, first of all, he discovered negatively charged particles. Now these particles which are present inside the atom, they are known as subatomic particles. That is the particles which are present inside the atom. Right? They are known as subatomic particles. Very small particles. Atom is itself a very small particle. So the particles which will be present inside the atom, they will be very small, beyond imagination. Right? Now J.J. Thomson, he discovered that there are negatively charged particles present inside the atom, and he called them as electrons and represented them as E with a negative sign, right? So first of all, J.J. Thomson, he discovered negatively charged particles, and Goldstein, this was before this, that Goldstein, he discovered some positively charged particle in a gas discharge tube. He observed some rays in the gas discharge tubes, and he called it as canal rays, and these were positively charged, right? So these positively charged particles, that means inside the rays there were certain particles which were positively charged, right? So he named them as protons, and this was represented as small p with a positive sign. So Goldstein discovered the positively charged particles. Two particles were discovered, the subatomic particles were discovered respectively by J.J. Thomson and Goldstein. That is electrons by J.J. Thomson and protons by Goldstein. Now there are certain properties of these protons. They had a mass 2000 times that of an electron, right? And this was approximately, the mass of electrons was approximately negligible, because it was 1 upon 2000 times that of a proton. So almost negligible mass. While protons, they had a mass 2000 times that of an electrons. And these protons, they were found inside the atom, right? And that is inside the nucleus. Protons were found inside the nucleus of an atom. Now how that nucleus was discovered, that I'll tell you just now. So these protons, they were found inside the nucleus, while it was observed that electrons, they are outside the nucleus, right? The charge of electrons is almost equal to -1, while the charge of protons is equal to +1. So this is +1, this is -1. That means they are balancing each other's charge. So atom as a whole becomes neutral, right? The mass was equal in magnitude, right? The mass of proton was equal in magnitude, but had a charge which was opposite to the charge of the electron. This was +1, this was -1. So it becomes neutral, the atom becomes neutral, right? Then later on, another scientist named Chadwick, he discovered neutrons, the third type of subatomic particle, and he named it as neutrons. The mass is nearly equal to protons. The mass of neutrons is nearly equal to the mass of protons. That means total mass of the atom is equal to number of, that is the mass of the protons and that of the neutrons. And they are also found inside the nucleus, right? They have no charge. No charge was found in the neutrons, so they are neutral, right? So this is about electrons, protons and neutrons, which are the subatomic particles. That means Atom is not indivisible, it is divisible, right? And it is divided into subatomic particles called electrons, protons and neutrons. Electrons, they are negatively charged, these are positively charged, and these are having no charge at all, that is neutrons. Right? Now, after this discovery was made, scientists started working on discovering the model of atom. How the atoms look like. First it was that this is the smallest particle which cannot be further subdivided. That's all. But when it was discovered, yes, there are particles in it, and those particles, the two of these, they have the mass also, right? So they started discovering on the model of the atom. Now in this also J.J. Thomson, he first of all worked on the model of the atom, and he said that the atom, it is neutral, right? It is they are equal, the negative and the positive charges. They are equal in magnitude, but because the charges are opposite, so they are neutral. And he said that atom, it looks like a pudding. Then he compared it to the pudding, Christmas pudding, that it is just like a sphere or a ball of a pudding in which the electrons are embedded, just like in the pudding some raisins are embedded. And he also compared it with a watermelon. He said that the red part which we eat, that is the protons, and the black seeds embedded in it, they are the electrons which are embedded in it. So according to Thomson, but then this theory was discarded. This did not work well. After that, Rutherford, he performed another experiment that is known as the alpha particle experiment, and he said that in the center of the atom, the whole mass is embedded, right? The protons as well as the neutrons. They are, first he said only that by that time neutrons were not discovered. So he said that in the center there is a heavy mass, the whole mass of the atom, right? This is the atom, and he said the whole mass of the atom is in the center, because when he passed the alpha rays, most of the alpha rays, they passed straight, right? But some which were passing through the center, they just rebounded. And some of the rays which just touched the center part, near the center part, they also got deflected. So that means something is present in the center which is not allowing the rays to pass through it. So he said that in the center, the whole mass of the atom is present. And this he named as nucleus. He said in the center there is nucleus which contains the mass of the atom. And he also said that this nucleus, it has 10 raised to the power 5 times smaller radius than the radius of the atom. Now you can imagine, atom is so small which cannot be seen. The radius of that atom will be so small, and the radius of the nucleus, that is the the one which is present in the center, that is 10 raised to the power 5 times smaller than that of the whole atom. Then he also said that the electrons, they keep revolving in orbits in the around the atom, right, around the nucleus, sorry. So what happens? According to him, if they are revolving around the nucleus, that means they will gain acceleration when they are moving. And when they will gain acceleration, they will radiate energy. When they radiate energy, they will lose energy and will ultimately fall in the nucleus. So if they fall in the nucleus, that means they are unstable. But we know that atoms are stable, right? They do not keep on changing their state of matter on their own. They are stable. So this theory had its own drawbacks. This was also discarded. Ultimately, Niels Bohr, he gave a theory which was approved. Theory around he discovered the model of the atom. According to him, he said that electrons, they always move in discrete orbits, right? They have their fixed numbers. Discrete orbit means they have their fixed number and they move according to that. So this Niels Bohr's theory was accepted, right? The electrons, they move in discrete orbits, and he also said that when they are moving in the special orbits, discrete orbits means in their specific special orbits, they will not radiate energy. So if this is the nucleus and the electrons, they are moving in these fixed orbits, right? Right? Now this, you can see here only, that is this he named as K, L, M, N, or first shell, second shell, third shell, fourth shell, and so on. This is how he gave the names, that the electrons, they keep revolving around the nucleus in these fixed orbits, right? And they do not radiate any energy when they are moving in these orbits. So then how electrons were distributed according to these shells, this I will tell you in the next video. Till now, what we have learned is that atom, first of all, it is divisible. It is not indivisible. It is divisible and it is electrically neutral, right? Then it is divided into subatomic particles that is electrons, neutrons, so the electrons, protons and neutrons. Electrons, they are negatively charged and represented by small e. Protons, they are positively charged and represented by P. And neutrons, they are neutral, right? One thing more that I want to tell you is that neutrons are present in the nucleus of all the atoms except hydrogen. So, neutrons are not present in the nucleus of hydrogen. Otherwise, they are present in all the atoms. And proton and neutron, they make the mass of atom. Right? The number of protons that are present, the number of neutrons that are present in the nucleus of an atom, that will make the mass of the atom. Right? So, proton plus neutron are present inside the nucleus. These two are present inside the nucleus, and electrons, they are outside the nucleus. They keep on revolving outside the nucleus. Right? I hope you all have understood this, and next time I'll tell you how that is known as the Borsbury scheme. How the electrons are distributed in their discrete shells, that is in the K shell, L shell, M shell. Then I'll also be telling you about the valencies, right? Then atomic number, atomic mass. We'll be talking about all that. Till then, you revise what you have learned today and keep studying. Stay safe. Thank you.